Before we really get things kicked off, just a couple of housekeeping items here. We're going to be sending the recording of this to everyone that's registered, as well as any kind of links, any information like that that we might cover later on in the webinar. But just to give an agenda of what we'll be going over is we'll do some panelist introductions, and then we'll dive right into the discussion topics. Right, we're going to be talking about the challenges of traditional robotic systems, kind of the emergence of plug-and-work robotic components, and we're going to be showing a live demo and a couple of different real-world application showcases of some of this stuff put into action. And then we're going to end that with some best practices, upcoming trends that our panelists are seeing, and at the end of that, we're going to hit a quick Q&A session with any time remaining. So any questions that you guys might have throughout the webinar, just go ahead and throw it into the Q&A chat, and we will dive into it at the end. But with that, let's move on to the panelists. All righty, so first off, we have Jake Hall, the manufacturing millennial. If any of you guys are on LinkedIn or any social media and follow the robotics world, I'm sure you've probably heard of him. If not, definitely check out his profile. He puts out a lot of awesome content. Next up, we have Blue Bay's own Pierre DeGiorgio. He's the president, founder, and chief technology officer of Blue Bay Automation, which is a company based out of Nashville that services the southeastern U.S. And then we have two speakers from Mechademic. We have Alex, who is over the pre-sales engineering, and we have Louis, who's the area sales manager of the Eastern US for Mechademic. I think one slide back. Yeah.
Okay. Yeah. Thanks for the intro there, JT. And again, a special thanks to Jake for joining us today. It's great to have you on here. So I think today what we're going to do is I suspect a lot of you guys out there who join us have either a little to a lot of experience with robotics. Some of you may not have a lot and just have identified the need and are interested in deploying robots. So, for those of you with experience, I know you're well aware of the complexities and challenges that you face in employing and deploying these robotic systems. But today we're going to try to highlight some of these challenges with traditional robotic systems, introduce you to the nature of open source plug and work type solutions, and hopefully provide you with some real world illustrations of these applications and the powers and benefits of an open source plug and work solution. So we're going to identify some key takeaways, inform you of some strategies, how you can streamline your operations and give you guys a competitive advantage. So let's discuss it. Yeah, if we go to the next slide. So I think Jake and I, we're talking a little bit about all of this, and most of us are familiar with the sort of the picture you see on the screen there, heavy industrial robots. It can be very intimidating to even see that, and for some of us that have had early on experience with traditional robotics, it can be quite challenging. We know why robots are typically used, dull and repetitive tasks, maybe dangerous tasks. Things people don't want to do or unable to do the heavy lifting or do things fast enough. So for the traditional integration type application, it can be quite difficult. There's many programming languages. They're typically quite proprietary, low level. I know, Jake, if you want to jump in here, I know that you've had quite a bit of experience on even programming these yourself.
Yeah, I mean, when you look at traditional robots for a long time, right? You going back to the 1960s, I wasn't around back then, but the Unimate was designed to really do that really boring old repetitive task. Like back when you look at the Unimate, the first one was literally programmed with toggle switches and a rotary program table, right? You would jog your X, your Y, your Z, you would rotate your dial. You had like a total of like 12 positions. You'd rotate your dial, you'd teach it its position, you jog to the next position, you rotate your dial. And, it was a very simple process back then. But, we saw over time where robots can now do more and more tasks that are out there that are making manufacturing a lot easier. But for a lot of times, though, there was always a very high level entry to when it came to robotics in the industry. And that's why we saw leading all the way up to really early 2000s, even later than 2010, leading all the way up to now, the automotive industry was the predominant industry. And that's what we're seeing in this photo here for a long time, right? You look at I think it was close to 85% of all industrial robots before 2015 were going into automotive. And that's because it was a very high labor intensive, demanded, industry that was dull, dirk, and, dangerous. And we're going to talk about it later in the presentation. But, now all of a sudden that we're seeing that now that robotics is a lot easier to use, you no longer need to have a doctorate or an engineer degree to program robots. All of a sudden, robots has become more of a democratized solution for a lot of companies. And how we go about integrating those robots is what's changing that.
Yeah, and I think we've seen sort of, that evolution in from, the pendant and these very low structured text type language, very difficult to write a full program. Would take a long time. Then the PCs came and then you could do some of that programming offline, still had to do most of it offline. And now we're seeing, with cobots and things as well, we're seeing, a much higher level programming environment where it's a lot of very graphical, drag and drop, very easy to use, but in some ways can also sometimes be limiting because, you can also make it too easy. So people still need the ability to do more advanced applications and get down to that lower level again. But still, when people have introduced these higher level interfaces, it's also kept it quite proprietary, right? So you get kind of locked in with that one manufacturer. So you're still having to learn a lot. So, I think if we can go to the next slide, we'll highlight some of these things here as well. I think the many programming interfaces have been the biggest challenge, right? So, as you go from brand to brand, whether it's a PLC brand or a robot brand, you're always having to learn that their interface, their language, they although some are quite similar, they're also, very different and intricate. So there's a lot of costs that many users have to incur on just to learn that new language. Some robot manufacturers even require you to be a certified and to go off to training. Takes time, takes money. And now you have these people that do have the specialized knowledge, but particularly for if any of you guys that have joined us are systems integrators, it can be quite challenging because, if you have to learn one manufacturer for one project and another for the next, you end up having to have, a lot of either a lot of people with different skill sets or a few people that you've had to spend a lot of time and money to get trained. So now those people have that specialized knowledge, which is great. And also in integrating these jobs, I think some of the biggest challenges that we've seen in my experience in the past is, you always got the different devices that need to talk to each other, right? So you've got the robot, you've got the PLC or controller, and the other peripheral interfaces that are part of the system. With traditional robotics, a lot of these sensors and things, it makes more sense to wire back to the robot, have that control. But now that has to talk to the PLC or the other upper level controller that's controlling the complete system, whether that's a PC or a PLC. So getting all these pieces to talk to each other and mesh can be quite challenging. And in some companies even have, robot specialists and PLC specialists. So sometimes now you have more people that also have to talk and interface and make all of this, work seamlessly. And then, debugging can be a pain in all of this as well. So as we're seeing, these integration challenges, many companies like Macademic, who's with us today, identified some of these pitfalls and have opened up their architecture to making the decision to say, let's not just introduce a whole nother robot language here that someone else has to learn. Let's make it simpler. Let's make people be able to program however they want to program. And what that allows you to do is, the ability to develop code, develop solutions, and then repackage and redeploy, which I think is a lot of value in that for end users, OEMs, and integrators alike, being able to take all the work that's been done and redeploy. It's hard to do that when you have, brand A, brand B, brand C, because it's all in a proprietary language. So we're starting to see more and more, people open to this sort of programming, where before, in many cases, we weren't allowed to do that, right? It was no structured text, has to be in ladder logic in our industry. And now as things are progressing, we're starting to see that open up a little bit. What do you think, Jake?
Yeah, I mean, you look at it, it's not just the integration side. I look at it as the educational side as well, right? When the biggest problem that I would say that's limiting the growth of the automation and manufacturing industry isn't the the cost of integration of robotics. It's the skilled labor force that's available to integrate that. And when educational facilities are having a hard time figuring out, okay, how do we create an academic curriculum that is going to prepare upcoming graduates either at a 4-year degree level or an associate's or a skilled trades level to prepare them to be a robot technician or a robot engineer. A lot of times there's such a steep learning curve, educational facilities don't know where to start. And I look at a lot of times that's what limits our industry, is because the entry level to robotic integration was so high. And I think what we're seeing now is, I would argue that was one of the biggest reasons why we saw the collaborative robotic market take off. Wasn't because they're safer. It's because a lot of times they were easier to use, right? They moved away from that very 1980s, 1990s industrial teach pendant that had more buttons than your TI-84 calculator when you were doing differential equations in college. You thought that was a lot of buttons. Wait till you picked up a robot teach pendant, and all of a sudden you're like, it's so difficult, especially for a small to medium-sized manufacturer who wants to look at adopting robotics and automation. They're like, hey, I'm used to running a press that has 5 or 6 buttons, and I want to do some basic machine tending, but my entry level is so high, it makes it super difficult. And I think that's one of those things where it makes it so hard as well when you have so many different programming interfaces that are out there, from robot brand XYZ123, it makes it tough. And the one thing that I think what we're seeing now is, in order for the industry to grow, in order for automation, robotics to be better integrated into our industry, the learning curve, the stepping stones to get from unboxing, to plugging in the robot shouldn't take you a 4-year degree to be able to do that. You should be able to go through some basic technical training, or in my opinion, you should be able to leverage YouTube University, right? When you look at younger generations these days, they learn more on watching YouTube videos than they do a lot of times going to college. I know I did that. If I had a question when I was doing, school, I was like, okay, this is great, but I'm going to see if I can go on YouTube and learn another way to explain it. I think that is the exact same thing when we're here. Is it needs to be able to be taught on a level that an entry person can understand. And this last bullet point, limited ability to redeploy, I think that's the other big thing as well. When we look into automation and why we're seeing automation being adapted in so many other industries beyond just automotive now, is because of the flexibility the robotic systems are being created, right? It was great for automotive because we were doing 2 million cycles per year of the exact same part over and over and over and over and over again. And it was one part one with one SKU number. But in automation and manufacturing these days, there's a lot more flexibility being designed into it. That's why we're seeing more like, vibratory feeder systems and picking systems and, multiple end-of-arm tooling, because it's not just the demand for automation is there because the labor force is going down, but in order to create a justifiable ROI, a task needs to do more than one thing. And I think in order for us to do that, there has to be a sense of simplicity across not just the single product of a robot, but then the integration to a vision system, the integration to an end-of-arm tooling, the integration to a safety system, the integration to a PLC. If you're using, Rockwell or Siemens or Mitsubishi or, an automation direct, you need to be able to have that streamline across the board. And I think that's where, in order to overcome those integration challenges, it really has to come down to the simpler it is to integrate, the faster and more rapidly it will be adopted. Not that it's cheaper, it's easier to work with.
Well, something I've seen a lot of too is it's been encouraging as we've been out there visiting potential customers, that we've seen a lot of new people being introduced to robotics that previously, many don't have any experience with robots, and it can be quite intimidating. So I think, the first thing we want to do is sort of kind of educate the customer and let them know it's not as bad as you think. It's not what you might expect in terms of, like you said, Jake, having a a 4-year degree and being, having to understand differential equations and all the intricacies of robotics. Most robot manufacturers have worked the difficult stuff out for you, but still, what I see is because many of them are proprietary, it kind of locks a customer. And so let's say a customer learns brand A of a robot, they tend to want to stay with that robot, even if it's not the right tool for the application. One of the unique things I'll say with, amongst many things I'd say with Mechademic is because it's a small robot, they do have a nice niche where people can consider them, but we've gone to several customers where they still wanted to put in that bigger robot because they're familiar with it. So having them see some of the key value points of Mechademic has been a key thing for us. And usually, Louis is going to speak to a little bit of it next slide here, but I think understanding the benefits of that and the open source nature of the robot, many, the young engineers that are coming out of school, they're able to pick up, Python or C++, or if they want to do it in ladder logic, they want to do it in a Linux-based system, or they want to do it on a PC, or if they're forced to do it on a PLC, that's okay. Mechademic's approach to the sort of open source is just that you do you. They've done all the heavy lifting inside their controller that's on board. But remember, there's no code that's stored on that robot. It's all based inside your higher level controller, so it all lives in one place, which will speak to some of the advantages of that coming up. But I think Louis, maybe this next slide, you can speak a little bit to that.
Well, thank you, Pierre and Jake. Wow, great synopsis, both of you. Amazing looking at the history of your experience, not only in the past, but the present and what's happening moving into the future on traditional robotics, plug-in work automation. And honestly, gentlemen, I feel things are already changing in the robotics integration game and landscape. They're moving fast. So I'm going to cover a couple of themes that we hear over and over, and we abide by, and we have a super approach to address them. When we talk about lack of complexity, we're looking at, Jake, what you mentioned is simplicity. Let's make it simple, right? The robot in itself and the integration of a robot is rather simple. The tough part is choosing the right partner from conception, inception, design, all the way to Q&A testing, all the way to a successful deployment. And that's why, with your experience, gentlemen, we have a Blue Bay Automation with us that has that expertise. And also, Jake, you're here as a subject matter expert to help customers along that journey. You mentioned also open source and languages. We're pioneers at Mechademic in terms of intellectual property, in terms of the language base, right? In terms of software developers combined with robotics engineers and mechanical engineers. So Alex, my dear colleague, always says to me and to customers, hey, use what you're comfortable with, whether it's C, C++, LabVIEW, or Python, right? So we're ready, and we've addressed this momentum and shift into the future. Lastly, integration with any PLC. PLCs are not going to go away, right? Let's put it that way. They've been there since, Jake, you were born in 1962, I believe I heard, right? So since 1960s, it's been around, right? PLCs are here to stay, and you can plug and work in automation through any computer also. So this is key. And Alex, my dear colleague and engineer manager, has already collaborated with the APIs and the documentation that are available around on Allen Bradley, Siemens, Omron, Beckhoff, you name them. So PLCs are here to stay. We just simplify and make it very easy as a little piece to a larger assembly in any industry that you desire, that you need the right solution for. Alex, all yours. If you can address a couple of these points, would be greatly appreciated.
Yeah, sure. Thanks, Louis. Maybe you can jump onto the next slide. So I'm going to do a live demonstration of all of this. But yeah, basically, what you guys said is all true. I mean, we see all of those challenges, and here at Mechademic, we try to approach things a bit differently. So Pierre, you mentioned that basically all the you can use whatever you like, right? So Python, C++, or ladder logic, or but we still provide a way to control the robot, a way to jog the robot, and this is through a web interface. So again, we try to keep things simple, so you don't need to install anything on your computer. You just open a web browser, enter the IP address of the robot here, and then you connect directly to it. So no need to install anything, no need to validate any license or all that kind of stuff. You just connect to the robot, activate the, let me just, okay, activate the connect as a controller, and now I'm ready to move the robot. So here on the left side, I have my jogging panel. Now I'm controlling the Mecha 500 here, the 6-axis robot, so I can jog it in a Cartesian space, in XYZ, or go in joint mode, and again, move it one joint at a time. And now I can start to build an application. I'm just going to connect to the SCARA here. So I'm just going to open a different web page, just connect to the different IP address. And again, I can move the robot here with this jogging panel in different joint modes, or Cartesian, or joint mode. So if I want to start building my application, I can just right click here, and then I have access to all the commands that I can send to the robot. So let's say I want to save this point here. I'm just going to select which type of move I want to do. So now I'm just going to go and move joints for the demonstration, just a tiny bit easier. And now I'm going to move to a different point. Right here, this way. And then save that point. So here, move joint, and I'm gonna move this right here. And once I've built that sequence of points, right, I can just hit play here, and the robot will recreate that sequence. So really, you don't need to understand do go through all the structure of a proprietary programming language, just a sequence of commands. Obviously, you can change the velocity or the accelerations or the reference frames, all that stuff. You can modify them, but it's just a sequence, right? And then what you can do is you can save that sequence here. So I'm just going to hit the save button and say BlueBay webinar. Click create, and now what I can do is I can just start a new program, and from here I can just say start program, and now it's BlueBay webinar, and I can hit play, and again the sequence is saved in the robot. So what I can do is I can start that sequence from anything. I can start it from a Python script, from a PLC, but I can also, if I prefer, I can also, the commands that I previously entered here, I can just send them from my PLC directly, or from my Python script directly. So I can really go on, like, however I prefer to approach this. If I prefer to save this in the robot, or if I prefer to host all the code in my controller, it's very flexible. And again, as like, there's many ways that you can send those commands. So we support TCP/IP, Ethernet IP, EtherCAT, Profinet. And all of these are included. Don't need any license or any special cards or any special things. Like, I've been a PLC programmer for many years, and just managing license and options and stuff, and sometimes it can be a bit painful. Here is just like, hey, I want to use this controller, or I want to build a special demo for a customer, but I don't have any controller. Oh, I have a Raspberry Pi here. Oh, let me just take that and build the thing quickly. I can do that with our robots. So there's no limitation, and you're not like, oh, I didn't buy that option for Ethernet IP, so I can't use it. Oh, you can. You just enable it, and you're good to go. You can use Ethernet IP. So yeah, that's kind of like the basics of how to use it. It's really this is closer to I would say kind of our teach pendant, right? So we don't have any teach pendant, but we have this, and it's provided for free. It's included. So you just connect to it with the normal computer, and you're good to go.
Yeah, Alex, I think it's worth pointing out too, just to avoid any confusion, because this is a concept that I had to grasp when we first started working with Mechademic, is that it appears as though, you of course you are able to save a sequence, a program in here. More traditionally, people will write out the full sequence like what Alex was showing earlier in your PLC or a higher level controller, because it's important to keep in mind that this unlike other robots in the market, because this robot is really designed to be operated with a higher level controller, it doesn't come with any I/O, right? So there's no inputs and outputs on the robot itself. Typically, what you're going to do is you're going to use your regular PLC I/O, for example, and interface it. So these commands and what you see here, it really is that simple. If you were to just do a raw TCP program and just send out the commands, what you see there, move joints, the coordinates inside parentheses, that's exactly what you send out from your PLC or high level control, and the robot will respond to that. So it really is that easy. But I do think it's worth noting that there's no I/O. So running a program sequence from your upper level controller sometimes doesn't have all that much utility, because you still may have to interface with sensors and things like, part presence and so on. But it is really a great way to test and prove out your program and your sequence before doing anything. It's really nice to have that digital twin as well. There is a way to run simulation where you can run this without actually moving the robot, just moving it on the screen in case you want to test a move and be sure that you're not going to damage anything or crash. You can test all of that out. The caveat to that is you do have to be connected to the robot because it still is interfacing with that. But it is a really nice feature that really and this new interface that they recently released here in the latest firmware is really, really useful and very, very simple to use.
Yeah, and just to add a bit on what you just said, Pierre, it's that with your approach of hosting everything on the controller, is exact, like, you can decide to do that, but you can also decide to do the other way. So, like, again, we decided to stay very flexible, and you can also do a hybrid solution. So if you want to have, some dynamic coordinates that are coming from a camera for, like, let's say a pick and place application, then you can send that specific command from the camera with those exact coordinates. But then, that part of the sequence where it's always the same movement, you just go to the place position or whatever, you can save that as a sequence in the robot and just do a hybrid solution. So here, if I press play, you'll see the robot will execute those 4 movements, and then it will re-execute the 3 movements that I saved previously. So it's and then this is still a TCP IP command. So you can just send this exact command from, like, a Python script or C# program or even LabVIEW, and then the robot will just execute those commands. So very, very flexible, and we try to give all the flexibility and the options to the customer.
Yeah, and it's also one of the things that I found, even with some of our young engineers, is that the barrier to entry with robotics for something like what you've just illustrated here, it's really not intimidating at all. It's quite simple. There's not a lot specifically about robotics that you need to learn. I will say this for any of you who are new to robotics, I highly encourage you to go to Mechademic's website and look through some of their documentation. If you really want to have a good read on robotics theory and understanding, TCPs and coordinate systems and getting deeper into the theory, there really is some of the best documentation that I would refer you to, whether you find yourself using a Mechademic robot or not. It really is quite educational.
Yeah. Oh.
All right. Thanks, Alex.
Yeah, no problem. It was a pleasure.
Yeah, so I think now, I think the next thing, what we'd like to do, hopefully, we've given you a little bit of a window into just a very, very brief exposure into the Mechademic interface. But really what we'd like to do is show you some real world applications, and hopefully you can relate to some of them. And we'll try to highlight some of the key points as to why using an open source system like Mechademic was beneficial here. So if we could jump in on the first application, this is one that we were involved in here personally. I'll tell you this was an automotive application that basically the robot was responsible for snapping these shields onto circuit boards that protected some of the circuitry. Traditionally, an application like this, if you were to use another robotic brand, some of the logic would have been inside of the robot. You see some sensors there. We've got a force transducer, and we've got a laser distance sensor. Traditionally, that would have been all tied to the robot logic, and then somehow we would have to communicate that back from the robot back to the PLC. In this case, because of the open source nature of the robot, it was all of the logic here was done in a PLC, and we were able to capture all that data directly with normal PLC logic. And furthermore, we were logging some of this data as well to a SQL database. But it was really a simplified control solution that really highlights why an open source plug and work system is beneficial. It was like I say, a really fast deployment from concept to application and to deployment. Again, on a traditional robot, a lot of this logic would have been in the specific robot. There were other reasons that a Mechademic robot was chosen for this, and we'll maybe talk about, Alex can talk to some of the specs later, but really there was a great deal of precision for some of the applications that was required here, and this robot was able to fill those needs. But before we move on to the next one, what I wanted to point out, with a plug-and-work system like this, remember that if you choose to not save any of the programs or program snippets in the robot, it's just a component in your system, just like, let's say, a variable frequency drive or a motor, right? So if something were to happen to this motor, it was damaged or something, just taking this robot out, putting another one in, maybe setting the IP address if it had changed, is all you would really have to do. There's no program to download. There's nothing to do to it. So simply go into the web interface that Alex showed you. You could set the IP address, and you could be back in production very quickly. Something that would not be the case if you were trying to have a problem with a traditional robot. So maybe the next slide there.
Yeah, thanks, Pierre. So I'm just gonna talk a bit about that application. So that was a great application where also no code is hosted on the robot. And it's one of those challenging application where every part is a bit different. And here what we're trying to do basically is align a cap to a needle, so for ocular surgery. And these needles are very small. And basically they are all a tiny bit different. So the way it works is we receive coordinates from a 3D camera system, and then we can align those two parts together. So here you can see that they are not perfectly aligned, and then we get those coordinates and then just move the robot a tiny bit to make them perfectly in line, and then we can insert the cap on top of that needle. So here what it shows is the great flexibility with the camera system. So you don't, for disintegration, you just receive the coordinates and the distance between the desired position and the actual position, and then you send this to your PLC, and PLC just send a relative movement to the robot, say, okay, you need to move 2 millimeters or to the right, and then robots compensate for the distance, and that's it. You're aligned. You can then continue on with the insertion. So again, no code hosted on the robot, and makes it very flexible and easy to integrate with vision systems.
Yeah, this was a great application done from one of our integration partners, Seymour. It was really highlighted the flexibility of the robot. Also, the precision, I think, in this one of the robot was extremely important, as you can see from the video.
Yeah, maybe I can just mention the precision quickly. So we are able to do actually 1 micron incremental movements in Cartesian space. So you can go to very precise positions with those, if the vision system support it, and if you have the resolution to do it, then the robot will probably be able to reach the position. So yeah, I think we can continue to the next slide. Yeah, so that video is just to show other types of application, right? So here we are more in the kind of automotive industry and inspection application. So here we're just gonna do some eddy current testing on that part, which is, I think, wheel hub assembly. So a lot of people think, oh, it's a small robot, it cannot really work in big environments like cars or stuff like that. Well, we can, it maybe not lifting the whole car, right? But some parts there, tiny parts, especially now, there's more and more electronics in cars, and that's the kind of thing we can do. And here you can see that wheel hub assembly, and the robot will just run that probe through that hub, and make sure, that the part is up to spec. And again, the code here is all hosted on the customer machines, and they can change different part. They have different recipes, but nothing changed on the robot. So you just say, okay, now this is this part or that part, and the robot will do the profile that is stored in our controller.
Excellent, thank you. I think next slide, there you go. I think this was a really fun one. I think Jake put together. Did we lose Jake?
Oh, I am here. Yeah. So this is just a fun example. I always like to highlight how robots could be used just for excitement and engagement. So this is a video I put together a couple years ago, actually, back when I was working for a distributor that sold Mechademic at the time. And so it's like an 8-second clip, but you can go ahead and play it. But I was going into the weekend, and of course, while Mechademic can be used for a lot of different tasks, one of the best ones is it can be a great beer opener as well. And it's a fun tool that way. So everyone else was contributing to fun applications. I figured I'd show my video of opening a beer.
No, that's great. That's robots can be used for anything, I suppose, right?
Absolutely, they can.
Fun. So yeah, I think basically, if we could offer some advice, and especially to those of you that are new to robotics or just considering robotics, it's always, I think, important to consult an expert if you can. Some of you have in-house experts, but many don't, and that's what we're seeing more and more of that. So whether that's you find a really good integration partner, a distributor who has engineering staff on premise who's very knowledgeable or experts with the product themselves, and even the manufacturer, like in this case Mechademic. Definitely, I think find someone who you can consult with, bring in, ensure that the application that you're trying to deploy is feasible. We do see that a lot where we, people bring you in and look at applications that are the most difficult, complex application, where in many ways you're walking by others that are the low-hanging fruit that could offer the quickest ROI, and also allow you to get some experience with robotics, and then slowly advance from there, and ensure you have a successful deployment, especially on your first foray into robots. But more than that, with these open source plug and work type application, it is a way of future-proofing your operations. Now, say that with a grain of salt, things do change a lot, but I think the best bet that you can do in trying to future-proof is, whether it's a robot or the PLC you're using, or whatever technology that you're trying to think ahead and see, can I redeploy this code? Is this going to be something that I can take from brand A to brand B? Right now, I will say that there are very few manufacturers on the market that are taking this approach. Personally, I think that they're missing the boat. I think that they're missing a very, very large opportunity to engage a lot of new people to automation. And I wish more manufacturers would take the approach that Mechademic has. Hopefully, you've seen some of that today. Keeping it open source allows us to do things like, we've done solved several applications here with customers by leveraging, existing open source APIs that are out there. People have done the difficult work of solving an application, getting access to data that's not traditionally accessible from a PLC. A very quick example of that is we recently were involved in a project with a customer pulling data directly from their Shopify account, pulling information down, sending it to a laser engraver. Traditionally, those sort of things weren't able to be done from a PLC, but because of the open source nature of the PLC we used, which was a Linux-based solution, being able to send commands to things like a Mechademic robot and interface those can really allow you to solve some problems that were difficult to do in the past, because others have also already solved them with their APIs. And there's often great communities online that are free and available to you. So in other words, don't reinvent the wheel if you don't need to, because it's possible now to do that. Jake, I don't know how much of that you saw when you were at your previous location, but I think that's one of the things that the biggest advice I could give people is consult an expert, do what you can to future-proof the application. If you've done it once, try to wrap it up where you can redeploy for other applications and save yourself some time and money. And then also, select the right mechanism for the application. A big 6-axis robot is not always the right tool for the job.
Yeah. And, I'm going to add one more onto that. And it's not so much technical related as it is just, in the first slide, we talked about how the industry is viewed as this dark, dirty, dangerous dull industry. And while robotics can be used as a phenomenal tool to solve your productivity issues and your labor issues, it can be used as a tool for industry attraction as well. And I think that's the other thing is when you're looking at this stuff, understand if you're looking at deploying robotics for the first time in your business, it's so much more than just a tool that's helping automate your progress. It's a tool that's changing the perception of how your future employees and also how your customers view you as a company. If you're leveraging the latest technology, you're leveraging tools that's driving things forward, they're going to view your company as someone that's changing and moving with the industry. And for me, who is so focused on bringing the next generation of millennials and Gen Zs into robotics and automation, leveraging these tools and saying, hey, look at the technology we're using is only going to be benefiting your company in the long term.
Yeah, and I think in this, even Mechademic realized, it started out with that Mecha 500 robot, which solved a lot of problems. I think, Jake, when you and I spoke yesterday as well, we were always begging for another mechanism because we knew that that 6-axis robot wasn't always the ideal tool for the job. Mechademic realized that, listened, and I think if we can go to the next slide, we're quite excited to that Mechademic has brought this new SCARA robot to the market, and it's going to solve a lot of applications with a 6-axis robot, although would be quite capable of doing it. The SCARA would be better suited. And Alex, I'd love for you to speak a little bit as to why you decided to come out with a SCARA and the benefits of it.
Yeah. Well, thanks, Pierre. Yeah, we really went with demand, right? So, like you mentioned, a lot of people didn't have any application where they required 6-axis, but they still wanted to have the ease of use and the precision and all the other advantages. But they wanted to maybe have a bit more speed or save a little bit of money. So that's why we decided to go with the SCARA. So, it's 4-axis instead of 6. So obviously it's going to cost a bit less, right? You have less motors, less gearbox, all that kind of stuff. And then you can go way faster. So just to give you some rough numbers, the 6-axis can reach around 1.5 meters per second, but then the SCARA is about 4.5 meters per second. So 3 times as fast, and you save money. So yeah, that's I would say that the main difference are these, but in terms of control, it's still the same way of doing it. We still have an integrated controller with all the communication protocols supported and the same kind of precision. So yeah, it was really from customer demands. People wanted to have something faster and cheaper. Yeah.
Great. I think we have a video showing the new SCARA.
Yeah, so this is a small application we built in-house. Basically, just show that you can fit multiple robots in a very, very small cell. So here you have one 6-axis and one SCARA doing an electronic application with a Siemens controller. But again, this could be really whatever you want. But it shows how compact you can make automation these days. So that cell there, there's nothing hidden under it, so it's hard to see through the video. But here under the table there, you could kind of see that there's really nothing. So it's just you could put that on the tabletop. So it's we try to stay away from those very, very big machines where you need to have whole rooms dedicated to them. So here you have kind of a compact application with multiple robots working together in a very precise environment. Yeah, and keeping the cost down again.
All right, thank you, Alex. Yeah, I think this next video is something that's what we call one of our pre-engineered solutions here at Blue Bay. We offer this as a package with some options and things, but it's again illustrates. This is a great application that just one of our demos that illustrates. In this case, you would need a 6-axis robot, right? So it's not always a one or the other. You want to pick the right tool for the right job. In some cases, if we're always working the same plane, one of our MechaFlex cells here, the pre-engineered solution, might come with as an option for a SCARA or the 6-axis you choose. We get a lot of interest in this, even from systems integrators, large systems integrators who really don't want or need to design the package that since we've already done the work. We were approached by a large integrator. This was a demo we initially built, and they asked if they could just purchase that as a complete cell to interface on an assembly line that they were doing. So this is something that we offer. Oftentimes we'll call this even our 80% builds, right? So we'll offer this with, let's say, a flexible feeder, as you see on there, the robot, the vision system, all ready to go, wired up, and you can program it. Or if you need help programming, of course, we're there to help you. But this is something that we offer as a solution. Okay. So I think just going back to some of the points that we highlighted before, the simplicity of integration, right? I mean, that's really what this comes down to. We really want to make sure that I think and Alex and Jay can speak to some of this as we finish up here, but things need to be easy, and today they should be easy. We expect them to be easy.
Yeah, like you mentioned, Pierre, I think the ease of integration, the flexibility to use whatever you already know is very important. We have a lot of customers that are actually software engineers, so they don't know anything about ladder logic or all those proprietary programming language. They know C# or C++ or Python, and they want to use that. So yeah, it's a perfectly good programming language. Like Python is proven, like everybody likes Python, so why would you need to learn something else, right? Just use that. And yeah, I think the simplicity and ease of integration is the two key things here.
Yeah, I was gonna say, just to add on to that one more time, when you're going out there and you're wanting to adopt automation for the first time, it's not the lowest cost solution that's always best. You need to figure out how all the different pieces and products work together, and from there figure out how you pick your partner that way. So that's just something to keep in mind. Understand, how does everything piece together? While you could have the best single ingredient out there when you're making your recipe, finding what ingredients work best together is what's truly going to make the best dish for you. And that's just why it's so important to look at the integration as a whole when you're developing systems.
Fantastic. Thanks, Jake. That's I think it's really important. So as you go through, and you consider what you've hopefully learned a little bit here today, please consult an expert, whether that's Mechademic, whether it's us or someone local to you. Definitely we encourage you to move forward on your automation journey. I mean, it's really for those again of you who are new to it, it's not as intimidating as it once was, and there's a lot of resources out there for you, whether it's again, your manufacturer, an integrator, or a distributor, but or someone in-house that you have. But I think now we're going to launch maybe some questions here. JT, is that right?
Yeah, that's right. We're going to launch a quick question. We're just going to leave it up for about 30 seconds or so. And then we're going to move into some of the closing remarks, upcoming events, and the Q&A session afterwards. So we'll leave this up for another 15 seconds or so, and then we can get started. So if you guys do have any questions that you want covered in the Q&A, go ahead and toss them in there, and we will, let's see, give that another 5 seconds, and we'll take that poll down. All right, appreciate that, everyone. Okay, so yeah, I guess just to conclude, so I don't know how many of the people that are attending right now are local to the Southeast, but you know, if you thought some of these demos that you saw and the use cases were cool, then we're going to be having Bluebay is going to be having a booth at 1521 at South Tech in Greenville, South Carolina, and we're going to be featuring 3 different demo cells. And also we're going to have the new Scara shown in action. So if you guys are entertaining the idea of attending that show, you can actually register for free using that link. And again, you know, no need to write it down. We'll be sending this out after the webinar as well. And then the other thing is Mechademic is going to be holding a webinar showcasing the MicroDash release line. So that's the Scara that you guys saw, and they're going to be covering kind of the formal launch of the line, success stories, a live demonstration of it, and more topics surrounding, you know, really just the future of micro automation in the industry. But yeah, so some good stuff to keep on the calendar there. But I think with that, we can go ahead and move into the Q&A session. So we had a decent amount of questions come in. I know we had a few come in during the webinar. It looks like most of those were answered. So we'll do some of the ones that we did not have come in yet. One of them was, Pierre, regarding the pre-engineered solution that you showed. They wanted to know, could you share some more information about the adaptability of the solution with the flexible feeder across different industries? How versatile is it really?
Oh, sure. Yeah. So, you know, that typically when, you know, we don't have a single part number for that, right? Because, you know, parts change size and things like that. So we offer that if the Mecha Flex cell with the that's an Aceral AsciCube feeder on there with the integrated I+ vision system. So that'll come in different sizes based on what your part requirements are. So if you have an application that you're interested in considering it, definitely let us know. We want to see the part size, and we'll talk through, you know, the right solution for that. One of the things also, there are a lot of options. One of the things I think I just wanted to touch on, Alex mentioned it very briefly, and you may have seen it in the last video that was just shown there, is that sometimes people discount or exclude the Mechademic robot from an application because of its reach. Something to definitely keep in mind, it is really easy because the controller and everything is built into it. It's very easy to move that robot right in a linear fashion. So that last video you saw, that we have the robot actually mounted to a Macron T-bot actually in that case, but it could be any linear actuator where we can extend the range of the robot, its reach essentially, whether that's in a linear fashion or a rotary fashion. So, but yes, yeah, so in terms of the Mecha Flex cell, really what we want to do is consult with the customer who's interested in it, and we will size it and adjust the components and on it based on the required specification.
Yeah, appreciate that, Pierre. All right, so the next few questions we had was regarding some of the specs, specifically for the Scara was the first one, and they wanted to know just what's the speed of the Scara.
Yeah, so speed can be complicated to explain depending on the movements and the payload and all that kind of stuff. But yeah, so max speed, compounded speed is around 4.5 meters per second. So that's like joint move at the end of the robot. But then again, if they want more spec, I can reach out after the webinar with all the specs.
Awesome. Appreciate that, Alex. The other one is, well, it's also kind of related to the specs, so you might have the same answer to it, but it's asking how precise are the robots, the Scara and the Mecha 500?
Yeah, so both of them, we have a precision, so a repeatability of 5 microns. We can do incremental movements that are smaller than this. But yeah, again, it depends. For the Scara especially, it's a bit harder in X, Y, Z. So X, Y, 5 microns, Z also. But then the rotation, I think it's a resolution of 1,000th of a degree. So you can kind of rotate the last shaft very precisely too. So.
Awesome. Appreciate that. Okay, and then there's 2 more questions that came in. One of them is asking if there's a teach pendant that comes with the Mecha 500 or the Scara.
Yeah, so no teach pendant actually. So the teach pendant is basically the web interface that I showed a little earlier. So you could technically run that web interface on anything like a tablet or something if you really want to have something in your hands. But the thing is that the robots are so small that you don't really need a teach pendant like larger robot where you would need to, walk in the cell. Really, you work very close to it. So most of the time, just your laptop works very well.
And I think tied to that is we've had the question come up before, because of the implied name, a teach pendant. We're not actually teaching points from the Mechademic web interface, right? It's a way to see the points and all that, but typically what you would do, and if you do want to teach a point with a push of a button on your HMI, for example, what you'll do is you'll use that to trigger a command that you will send down to the robot to read the current position. It would return for example, let's say the X, Y, Z, theta coordinates on the SCARA, and then you would just record that position for later use when you want to send it back down to the robot to command that move.
Yeah, exactly. Yeah.
Perfect. And then the last question that we had put in is asking if the Mechademic robots are collaborative robots in nature.
So no, they're not collaborative robots because there are some pinch point, right? So it's built like an industrial robot. I would say that the robots are not that powerful. So you kind of like, it's not a scary robot, but because of the pinch point, you still need to do a risk assessment. But that's also true with collaborative robot, right? So it's not because it's a collaborative robot that it's safe. You still need to do risk assessment. I always say if it's a collaborative robot with 20 kg payload on it and it hits you, it's still going to hurt even if it stops, right? So risk assessment is always important with any robot, and us is the same thing. So
Perfect. Yeah, well, I think that that is all the questions that we had come in, and looks like we might finish 2 minutes early, but I think we'll cap things off by just saying, oh wait, actually, we did get one more question that came in. Alrighty, let's see. Does Mechademic provide any robot training setups?
yeah, so most of the time when you buy a robot, you'll get a training that is included, and that training normally lasts around 2 hours. So since you don't need to learn a new proprietary programming language or anything, normally in 2 hours you kind of understand how to move it, how to jog it, how to teach points, and that's included with the robot.
Awesome, appreciate that. All righty. Well, I think that just about concludes everything. So again, everyone that's on, we'll be sending a recording of this to everybody. And, if you have any questions in the meantime, feel free to reach out to us at, bluebayautomation.com, reach out to Mechademic, Jake Hall, whatever's easiest for you. But other than that, thanks Jake, thanks Pierre, thanks Louis and Alex for, going over all this in such detail.
Absolutely. Thanks for having me.
Thanks, GT.
Yeah.
Thanks, Pierre.
Thanks everyone for attending.
Thanks,
Appreciate
Rick.
it.
See you guys.
Bye-bye.